Hello students, in this video we are going to discuss FSK demodulator. FSK demodulator we are using at the FSK receiver. So modulator we are using at the transmitter, demodulator we are using at the receiver. So we are going to discuss FSK demodulator with respect to the coherent and non-coherent. So coherent means we need the fixed phase of the carrier frequency at the receiver side, and also synchronization circuit is required. So the coherent based FSK demodulator works in efficient and effective way with high accuracy in the noisy environment. But in the non-coherent, we are not using fixed phase of carrier signal, and also we are not using the synchronization circuit. So it is very simple to design, and but accuracy is very less in the noisy environment. Now we will discuss the non-coherent FSK demodulator using this figure. First we will feed the FSK input signal to the power splitter. The power splitter splits the power of carrier signal, okay, splits the power of FSK input, right? So, and based on the power, it feeds the signal to the band pass filter. For example, so for the band pass filter, it receives the space frequency, and the second band pass filter receives the mark frequency, right? The output of the band pass filter, the first band pass filter is a analog space frequency, and second band pass filter is a mark space frequency, and these two frequencies are given to the respective envelope detector in order to detect the power of sidebands. Power of sidebands of space frequency in the first envelope detector, and the second envelope detector detects the power of sidebands of mark frequency. After that, the output of envelope detector is given to the comparator. This is the comparator. It compares the power of two different frequencies, that is space frequency and mark frequency. So if it is the power of the space frequency is greater than the mark frequency, then the output is 0, right? So if the power of mark frequency is greater than the space frequency, then the output of the comparator is 1. So based on the power of space frequency and mark frequency, we will get the output of the comparator, right? So the power of space frequency is greater than the mark frequency means we will get 0. If the power of space frequency is less than the mark frequency means we will get the binary in output as a 1 at the output of comparator. In this way, we are going to detect the original signal from the FSK modulated signal in the non-coherent detector. Here we are not using any fixed carrier phase, okay? So in the non-coherent detector, and also synchronization circuit. So this type of circuit is called non-coherent FSK demodulator. Now we will discuss the coherent FSK demodulator using this figure. So it is as same as our previous figure, but here the carrier comes to the picture, okay? So here we are using mainly two components. One is a power splitter and correlator. Finally, in order to compare the two signals, we are using the comparator. So similarly, what we discuss in the non-coherent detector, so the power splitter splits the power of carrier FSK modulated signal and given to the correlator. The correlator consists of multiplier and one bit integrator, right? A one period integrator. It integrates with respect to the one bit period 0 to 2b. So in the multiplier we are using the two carrier frequency. So one is for the, these two frequency are the, here these two frequencies are mark frequency and space frequency. So the FSK detector consists of two correlator with locally generated carrier. So the locally generated carrier is a, one is the mark frequency, another one is the space frequency, right? So and the output of each multiplier is given to the integrator in the respective integrator. Then the output of the integrator is S1 of t, right? S1 of t and S2 of t. These are the two outputs of our correlator. So here the comparator compares the these two signals. The S1 of t is greater than S2 of t, then it is a mark frequency. S1 of t is greater than S2 of t, then the output is logic 1, right? It is a mark frequency, isn't it? So if it is mark frequency itself, we will get the logic 1. If it is space frequency means, for example, if S1 of t is less than S2 of t means, that is our output is logic 0. That is our space frequency, isn't it? So based on the output of correlator, right? So we can able to decide which is our logic 1, whether it is a logic 1 or it is logic 0, or the output of our comparator. So if S1 of t is greater than S2 of t, it is a logic 1. S1 of t is less than S2 of t, then it is a logic 0. Here we are using the locally generated signal, that is a mark frequency signal and space frequency signal. So that's why it is a coherent detector, FSK, or coherent based FSK demodulator. I hope you are able to understand the coherent and non-coherent FSK demodulator. Thank you.